So how are you? Are you doing well? So for the exam tomorrow, I just want to say one thing. Don't be late, okay? So I want to start at 4. So please come at least 2 to 3 minutes before 4. Very important. So my plan today is to try this past exam together. I believe you have enough time to try them, right? So can I just randomly select a few in class and maybe you guys can present your solutions? Do you think that works? Have you tried, by the way? Can you raise your hand if you at least tried to solve some of the questions? You only have 1 day left. So if you haven't, then you are in trouble. Okay, so then can I have some volunteers to solve example 1? Can I have 2 volunteers? Maybe 3 for A, B, and C. Who want to do question number 8? What is beta hat for the slope? What did you get? Okay, so this is excellent. So did you get 0.009 too? This is for the slope. Okay, so it's the sample covariance and sample variance. There is a 1 over n minus term, right? But that canceled away. So they just use the summation. So the ratio makes a slope coefficient. And it also says interpret them. So in the exam, when the question says interpret, then you really have to give some interpretation. Otherwise, you lose at least 50% of your points. So when we increase the weight by 1 pound, the weight is x. The height goes up by 0.009. What's the unit in the dependent variable? It's meter, right? 0.009 meter. So that's 0.9 centimeter. Okay, so if you increase your weight by 1 pound, the height goes up by 0.9 centimeter. That's the interpretation. So this is the formula for beta null. So you just plug out the number and you get 0.38. Did you get the same answer? Did you get it? Okay, this is excellent. Part B, predict the height of a child whose weight is 90. So we use this regression line, the sample regression line. When x is 90, you just evaluate this. So the answer is 1.19, again, meter. So here, the unit is very clear, right? Unit for x and y is very clear. So I want you to write down the units specifically. It's very important, actually. So that's B. Did you get this answer? Did you get it? How about C, r squared? So basically r squared is equal to sample correlation coefficient squared, right? So you calculate the sample correlation coefficient and you square it. So you plug in number, and that's how you get the r squared. The answer is 0.486. Did you get it? Okay. If I ask a question like this tomorrow, do you think that you can solve them? I may ask. Okay. So we'll do exercise 2 shortly together. This is very important. I just want to make sure that everybody can do it this time. I think about 20% of my class was not able to run a regression in the quiz, right? So if you are one of those who couldn't do it, you have to fix the problem. This is the second time, right? So you should do better. So we'll do it together. Now let's consider example 3. It's basically the same thing, right? By the way, in the last year, I allow my students to use R to calculate variance and covariance. So you don't really have to do it by hand. You just type variance of this data, covariance of this data, okay? Now I want to try them. Can I have volunteers? So here the difference is I don't give you summation of x and summation of y. Instead, I just give you x and y data, right? So you can use Excel and you produce this variance and covariance, right? You can do it, right? Not Excel. You can use R. So this is variance of x, variance of y. This is covariance. And you use the formula for beta hats, 1 and 2. So these are the answers you should get. Did you get them? Did you get the same answer? Now, once you estimate the regression line, we can use it for the prediction. So C says, use a regression line in B and compute the predicted value of the house number 10, Y10. What does it mean? The 10th house. What is the value of x? The 10th house in the data? X is 20. Okay, so we use 20 in x. Then you can calculate y hat. Now, what is the prediction error, the residual for the 10th house? The residual is actual y minus your prediction, right? So y10 is given in the data, 204, and you subtract your predicted value, and that's how you get the residual, the 10th house, right? X and y are given. You can make your prediction, and you can even figure out what is your prediction error. So that's how you do it, okay? Now this is one of the very typical question. What is the changes in y? The change in x times beta, right? Effect of change in x. So we do not know beta, so we can estimate it from your sample. So that's 7, basically. Changes in x is 2.7. So you can get the changes in y. So you increase the size of your house, right? So the price of your house actually increases, goes up by 18.99. Okay? So it increases. So that's how you solve question like example 3. So if I ask this tomorrow, can you do it? Okay, you should. Okay, let's move on to example 4. Now let's compare example 1 and example 4. What's the difference here? What's the difference between two questions, example 1 and 4? Do you remember this? The shortcut for the sample covariance? So in example 1, this is given. In example 4, this is given, right? So the point is, you remember this formula, and from this, you calculate the original thing. That's good for the sample covariance. So example 4 is slightly harder than example 1. There is one more step, one more layer. So use these informations, figure out these three things. Then basically you're back to the example one, right? Which is easier. Okay, if you haven't, why don't you try it right now? And find some volunteer. So if you figure out these three things, you can just plug it into the formula. So that's what she did. Okay? So you plug in these numbers, and the slope is 4.7, intercept is minus 19.7. Did you get these numbers? Just, by the way, let me just write down the number that I got. This is about 175. This is about 36. This is about, this is what I got. So you can plug out those numbers over there. Should get these answers. Okay? Now again, R squared is the sample correlation coefficient squared. So when you get these three numbers, by the way, you just divide everything by n minus 1, right? So that's why you have a different number. This is before n minus 1, this is after n minus 1. So you can plug these numbers to this formula. R squared must be 0.62. Now what's the interpretation of this? What's the meaning of this? 0.62? How do you use this number? (62% of variation in your dependent variable is explained by the regression line. Okay, so that's the R squared. For the SCR, you have to remember this formula, right? So we need SSR. So where did the SSR come from? It's from this formula again. So there's a lot of formulas you have to memorize. So TSS is here. This is TSS. And we know that R squared is 0.62. So you can figure out SSR, right? TSS is known, R squared is known. So you can find out the SSR. You plug this SSR to the formula. You can figure out the SCR, which is 4.2. Again, this is a very typical question in regression. I may ask this too tomorrow. Do you have any questions in this example? Is everything clear? So are you ready? If I ask something like that, can you solve it? Okay. Example 5 is, so it's a kind of question that if you just figure it out, that idea, then you can solve it extremely easily in a minute, the whole thing. You can just do it in a minute. If not, it takes a lot of time. Who tried it? Any volunteers? By the way, my slope is 53.47. My intercept is 26.9. Did you get the numbers? Did you get the numbers? Why don't you come on out? Usually in example 1, it's sample covariance of x and y divided by sample variance of x, right? Because x is your y is your x, it has to be the sample covariance of your y and x divided by sample variance of your y, right? Now what happened to the numerator? So Matthew changed the denominator to sample variance of y. but he didn't seem to change anything in the numerator. What happened? Sample covariance of x and y is equal to sample covariance of y and x, right? That's why there's no change in the numbers. Actually, this is one of the questions in your homework, right? Do you remember homework 5? So what's the number of the exercise? Is it 4 point something? One of the last questions. It says show that the r squared does not change even though you switch x and y. Okay? So the trick is the big R squared is this sample correlation coefficient squared. Sample correlation coefficient x and y is sample correlation coefficient of y and x. So that's why. Okay. By the way, on this topic, let me just say one thing. So when I say regress wage on age, what I mean is wage regressed on age. So this is correct. What is not correct is age regressed on wage. So don't be confused, okay? Confused about how I use the word here. So this is correct, this is not. So please, please, tomorrow, don't do this. Don't do this. It's important. So typical way of saying this is we regress the dependent variable y on independent variable x. Okay, so that's how you say it. If I ask you tomorrow, can you do it? Okay. Now let's consider example 2 together. So why don't you open R and do it? So why don't you do it? Okay, it says run a regression of average hourly earnings. So that's your Y, right? On, so we have X, age and bachelor. So that's how you run a regression. Average hourly earnings, that's your Y. Now you have two independent variables, age and bachelor. Okay, you put them both. This is one example of multiple regression. We haven't done it, but at least you know how to interpret this, the coefficients. So what's the meaning of this 0.6? You increase age by one unit, means you become 1 year older. Your hourly wages goes up by 0.6, 60 cents, because the unit is $1. Now this gets 1 for college graduate, 0 for non-college graduate. So if you increase the bachelor dummy by 1, what does it mean? You have a person, you send him to college and let him finish, okay? So once he has a college degree, the wages goes up by $7.57. So that's part A. Part B, John is a 33-year-old college-educated worker. Predict John's earning. So this is how I do it. So, you know, the idea is that we use the regression line. This is slope, this is intercept. You have two slopes. So you have beta null hat, beta 1 hat, and his age is 33. Beta 2 hat, and by the way, he has a college worker. So his bachelor dummy is 1, right? So this is going to be his predicted income, and he doesn't have a college degree. Okay, let's see C. The age and education, two independent variables, collectively account for a large fraction of the variation in earnings across individual workers. What does it mean? What's the question? So the question is, what is the R squared of the regression? So how do you find out the R squared? Figure out the R squared. So the R squared is in this summary. Okay? This is the R squared. The multiple R squared is actually the R squared. Usually we run a multiple regression, so that's why. So don't make a mistake. This is not the R squared we are looking for, okay? So do not use this number. You have to use this number, the first one, okay? Multiple R squared is the R squared we know. So that's 0.168. What does it mean? I think you know, okay? Okay, let's go to D. What is the standard error of the regression? And what is its meaning? Where is the SCR? This is the SCR. Standard error of the regression is this one, 9.2. Okay? So this is the R squared, this is the SCR. The two useful things we are going to use. Now what does it mean, 9.2? So previously we predict John's income, right? And we predict that his income is going to be $24.82. But again, it's impossible to predict someone's income exactly. The prediction will be wrong. By how much? Typically by $9.2. So to be safe, you can say that John's income will be $24.80 plus minus $2.20. Okay? So you give a wide interval as your prediction. That's safer. So that's how you use SCR, okay? It's a typical size of your prediction error. Again, I think I can promise you that I'll ask something like this tomorrow, and I expect that you can do it, okay? Without an exception, everybody should be able to do it. So this is something like a minimum that you have to show me to demonstrate that you are making some progress. Okay, so I have a few comments left. By the way, do you have any questions so far? I have a few comments. In the past exam, this is an exam last year, the last 4 semester. It's kind of regression heavy, right? It's because 2 classes are different. It covers different topic, a different pace. Your exam may not be exactly like this. Do you understand what I mean? Because you learn something else too. So again, it covers chapter 2, 3.1, and chapter 4, right? But this exam is mainly from chapter 4 and chapter 6. So the way we cover the material is kind of different. So expect that. And again, what's the best way to prepare? Let me remind you these things. So if you haven't done this carefully, please read it again and prepare accordingly. It says chapter 2, 4, and 3.1. And the remaining things are kind of the order of importance. So as I said, you have to redo every homework, but 4 and 5 are the most important one, okay? So don't forget about it. Make sure that you do the quiz again. And I said there will be an art question too. So make sure that you know how to save your data, how to read it, how to run a regression, and solve the sample exam. The past exam we just did together. And if you still have some time, a really good thing is solve the exercises in the textbook. Some of them are really good. Okay? A little more difficult. So if you have questions, you can come and see me. Or just send me an email. You can just answer it very quickly, or just send an email back to you. Otherwise, I just ask you to come to my office. Okay, any questions? Nope? Okay, I'll see you tomorrow.